Alright guys, so this is Mr. Zabo. I want to take this opportunity to go over these proofs. I have them written out here. I've posted the answer key in our classroom. I wanted to talk through them as well to give you a few different modes of communication here. In this one, it was just a three-step proof, so it is a simple addition proof because we have the two small parts being congruent, and then we are adding one piece, and we're adding the same piece, but we just need to state that it's addition or addition property. So we started getting a little more complex on number two. In number two, there's two things that we have to assume from the diagram. Okay? And my order in which I've written this proof does matter. So I did assume that my angles were vertical angles, so angle EBA and angle DBC. I assumed they were vertical, that's why they're congruent. I can't state that they're congruent until I've assumed they are vertical. Now I use my given statement, and I can combine statements 2 and 3 here using the transitive property or substitution, both would work, to state that angle JGH is congruent to angle DBC. And again, angle JGH is congruent to EBA, which is already congruent to DBC. That's the transitive property. Then I'm assuming that angle FGH is a straight angle. Therefore, angle FGJ is supplementary to angle JGH. And if FGJ is supplementary to JGH, then it has to be supplementary to DBC using substitution, because we know that angle JGH and angle DBC are congruent from step 4. Here in number 3, again, this can be just a 6-step proof. It can be done in a lot more steps, but I tried to outline it up at the top here. We have midpoint, midpoint, congruent. The congruent statement is that segment MN is congruent to segment RQ. Those are small, and because N and R are midpoints of OM and SQ respectively, that's the multiplication property. That is, we're multiplying a congruent segment and we are getting a larger segment. I can state segment OM congruent to segment SQ by multiplication. So I showed that in a flow proof format up here. Combine that with the segments PO being congruent to segment TS, and I can add OM and SQ to PO and TS and get my final statement. So number 4 was definitely the most complex proof in this bunch, and so I'm just going to go through it right now to start my flow proof format up here. Okay, so what I did was I looked and I knew I needed to prove that segment EFH is going to be congruent to segment ABD. So one thing I noticed that from my given information, I was able to determine that we had segment HFG is going to be congruent to segment DBC. So I'd have to figure out a way, and I did that here, and I'll get to that, to show those congruent. And then I used supplementary theorems. We could have used congruent angle theorems, that straight angles are congruent, and then use subtraction property. Subtract our congruent angles here, and that would have gotten there. So there's a couple of different routes to go with this. I chose to do the supplement one primarily because I wanted to review that one with you guys. But you could have gone straight angles to congruent angles. Okay, so I said straight angles because we need to assume that from our diagram. Implied angle EFH was supplementary to angle HFG, and that angle ABD was supplementary to angle DBC. Now I have two supplementary statements. The fact that my ray bisects angle JFG tells me that angle JFH is congruent to angle HFG. Combine that with the fact that angle JFH is congruent to DBC. The transitive property or substitution would tell me that angle HFG is congruent to angle DBC. So that's the steps I have to take using my givens to make those angles congruent. Then I'm going to take my two supplementary statements and my congruent angles, and I can finally make my last statement. So if angles are supplementary to congruent angles, then those angles are congruent. The other option I could have done was straight angles to angle EFG being congruent to angle ABC. And then if I have those congruent angles stated, with these congruent angles stated, I could have gone to this with subtraction. Okay? Here's how that looks in a 2-column proof. First I showed my smaller angles, HFG, congruent to angle DBC, in order. I followed the logical order to make that conclusion. Then I assumed straight angles, stated supplementary angles, and then I combined this last step with step 4. So 4, 6, and 7 allowed me to do number 8 here. Okay? Again, I like to think these through sometimes in a flow proof format. That's the way my brain works. That might be a beneficial thing for you guys as well. All right, so that's it for the flow proof part of this. I am going to try to come up with another video to go over some of the common ideas in the Chapter 2 review, and then there are some other problems that you guys can be doing for review as well. Please feel free to email me. Let me know if you guys have questions.